So next, let's prove the trig identity. So this is example 1.26. So in example 1.26, you're supposed to prove that 1 plus tangent squared equals to secant squared. So 1 plus tangent squared theta equals to secant squared theta. Remember, this means tangent theta squared. Very important, so you don't get thrown by the different notation. So how would you prove that? How are we proving it? You're proving it from this. Sine squared plus cosine squared equals 1. You're always proving it from something. Okay. Otherwise, you can't prove anything. There's nothing to prove if you don't have a foundation to prove it out of. So right now we're proving it from that thing. So how would you prove it from that? The two don't look anything the same. Well, you just write that down and then beat it around and hope that something shakes out. So let's we'll write down sine squared theta. Oops. Let's see. Let's get rid of that line. Sine squared theta plus cosine squared theta equals to 1. That's the Pythagoras theorem. And so, okay, now what? Now let's divide it by something. Okay, what are we dividing it by? Tangent. Okay, let's see. Tangent is sine over cosine, right? So let's. Where is yeah, tangent is sine over cosine. Let's make tangent happen and see if anything interesting comes out. That's the only reason I'm doing this is because there's a tangent there. This tangent equals sine of cosine. So let's divide everything by cosine. Then you create a tangent. And why would that prove anything? Not necessarily, but we are just trying our luck. Some of math proofs, especially in algebra, is just you do something and hope that everything falls out. So sine over cosine becomes tangent squared. So you're making this look a little bit like that. But all this don't look like it yet. And then cosine plus sine equal cosine over cosine is just 1. Okay. And then the last one, 1 over cosine is, remember what 1 over cosine is, and you have to look it up and find out that it's equal to secant squared. And that, it just happened that that's it. That's a quick and easy proof. However, sometimes you have to beat it a lot longer, okay, to continue to make it look a little closer and a little closer until it finally gets there. It's just a matter of randomly do something that's somewhat sensible and hope for the best. That's how you prove trigonometric identities. So, okay, move along. Let's talk about the graphs. Right. So the graphs of sine, cosine, tangent, you should have a vague idea what it looks like. And of course the sine graph is very famous because the sine graph looks like an ocean wave. See, a beautiful ocean wave. And so does the cosine graph. The cosine graph and the sine graph look identical, except that they're shoved over by pi over 2 or some other such number. Depends on your sine, what's happening to your sine. But basically, you just remember the sine is a motion wave that doesn't ever change. It just goes up and down, and so is the cosine. And the difference is that the tangent is very different, and the reason being the tangent is sine over cosine. So there's a denominator here. So anytime the denominator approaches 0, then you have something approaching infinity or doing something odd. So the tangent graph generally looks like this. That is, cross up. It doesn't bend back. Nothing ever bends back, by the way. Yeah, things only go up, but they always go forward. Anything that bends back is not a function. Okay, so that's tangent. Okay, that it goes like this, or flipped around the other way around, if it's a -1 or something. So that's basically the idea. So the tangents have asymptotes, where I think, it has asymptotes, which we will talk about later. And the point is, the tangent does this, and the sine and cosine does that. And that's about all you need to remember of that for now. And with that, we get to the end of this particular section 1.3. I'm not going to assign any homework because we're still in the review stage. We haven't gotten to calculus yet. Once we get to calculus, then we'll do some real homework. So for now, let's finish this and make sure you remember what sine cosines are and stuff like that.